Hey guys, in this video I'm going to talk about how to add rational expressions. In the next video I'm going to do one on subtraction, but for now let's just stick to addition and let's see how they connect. So these are going to be the types of problems we're going to be seeing. We're going to be dealing with examples that are combining two rational expressions. Here we have it in factored form, and then here notice how we have them in standard form, and in one of them is in factored form. And we're going to be talking about those two scenarios and how to combine like terms. So before anything, let's talk about and slightly do a quick warm-up on adding fractions. So go ahead and pause this video and try doing these as a quick warm-up. See how much we remember back from 4th and 5th grade. All right, so if we think back, way back, whenever we're combining by adding and subtracting fractions, we'll talk about just adding for now. When we're adding them, we want to make sure that the denominators are the same. So here we have 5 and 5 as a denominator, which means all we need to do is combine the numerators. And we get this. And the top we get 4 plus 3 is 7. And in the bottom we have a 5 as a common denominator. On the other fraction, this next example, notice how we have a 4 and a 5. We cannot combine the 3 plus 1 just yet because these two are not common denominators. So the first thing we need to do, and this is going to be the most important part for the rest of this unit, or for this section of the unit, is we need to make sure these two are common denominators. So, what do 4 and 5 have in common? Well, we can find the least common factor, or the least common multiple, and the LCM, where we multiply these two. 4 times 5, we get 20. So 20 is going to be the least common multiple that these two numbers have in common. So, since we want to get 20 as the least common multiple, we need to multiply this fraction on the left times a 5. And we do the same on top. We're multiplying top and bottom times 5. And on the other fraction, we're going to multiply the 5 times a 4. And we need to multiply the top as well by a 4 to keep the fractions balanced. Now, when I separate these two problems, I'm going to combine these, and on the top I'm going to have 3 times 5 is 15. And the bottom, 5 times 4 is 20. The other fraction we have 4 times 1 is 4. And in the bottom we get 4 times 5 is 20. Now that we have a common denominator, 20 and 20, we can combine the numerators. 15 plus 4 leaves us with just 19 over 20. So the biggest and most important thing here is going to be finding this common multiple, or the least common multiple that they're both going to have in common, so that we can then combine the numerators. So now we're going to take this and we're going to move it over with variables. All right, so notice how here we start with these examples where we have common denominators. So there's nothing to do other than combine the numerators. We're going to combine the numerators and simplify our fractions. So in the first example, we have 4x plus 10, leaves us with 4x plus 10, divided by x plus 2. On the other example, we have x plus 1 and 2x minus 4. So when we combine the x and the 2x, we're going to get 3x. And the 1 and the negative 4 gives me negative 3 over 3x squared. Now, notice how there's a lot of 3's in this problem. So in the numerator, I have a 3x and a 3 in common. So I'm going to factor out a 3 from both of these. And I'm left with 3 times x minus 1. This is from the previous video on multiplying and finding common factors. We're going to divide this by 3x squared. Notice how there's a 3 on top and on the bottom, so we're going to go ahead and cancel those out. And we're left with x minus 1 over x squared. On this other example, we could have factored out a 2 because they both have a 2 in common, and if we try that, notice how we take out a 2, we're left with a 2x plus 5 divided by x plus 2. The The thing about these, the reason why we didn't do that is because these two are not common terms and they're not going to cancel. So there's no need to find the factors of this one to this way. So our actual solution was what we had before. So we can go ahead and get rid of this piece down here. All right, as we move on to more complex ones, remember the goal is to have common denominators so we can combine the numerators. Go ahead and pause this video and see what you got. Go ahead and pause it and try it out. See if you can combine like terms, see if you can make them the same, and let's see where we go from here. Okay, so notice how these two fractions are not the same denominator. I do notice though that this 5x and the 15 have a 5 in common, so I'm going to go ahead and factor out a 5. If I factor out a 5, just 1 second. If I factor out a 5, I'm left with x plus 3. Remember, a quick way to check this is to do distributive property, and if this multiplies inside to give you the same thing, you factored out the 5 correctly. On the other one, I leave it the way that it is. So we do 4 over x plus 3. Then we still have the 8. All I did in this scenario is I changed this 5x plus 15 to 5 times x plus 3. The reason why I did that was because I noticed that these two denominators are very similar to each other. Here I have a 5 times x plus 3, and here I just have an x plus 3. I'm missing a 5 in front of this other fraction. So I'm going to go ahead and multiply this times a 5 so I can make them common denominators. Now by multiplying it by a 5, I'll do it in a different color so you can see how it stands out. If I multiply this times a 5, to make them the same, I need to multiply the same thing on top so that I can simplify and keep this fraction the same. Now when I do that, I have on the left the same thing, 8 over 5 times x plus 3. And on the right side I have 5 times 4 is 20 over 5 times x plus 3. Now that we have a common denominator on both fractions, I can combine the numerators. 8 plus 20 is 28. So I have 28 divided by 5 times x plus 3. Is there anything that I can cancel or divide here with the 28 and the 5? And the answer is no, there's no common terms. And that is my answer. Let's try another one. Go ahead and pause this, try it yourself. Notice how these two are still different common denominators. We want to make them the same. So, pause this video, go ahead and give it a try. Okay, so here, let me show you how to do this when both terms are completely different. There is nothing that I can factor out of this one or out of this one to show that they are the same. So, when I have that they're different, I'm going to go ahead and multiply each fraction by the other term. So I'm going to agree first that the common denominator has to be both of these denominators combined. X plus 2 and x minus 5. When both terms are completely different and they have nothing in common, I'm going to have to multiply each fraction by the opposite denominator. So I have an x minus 2 and x minus 5. This is what I want my final answer to be in the bottom. So what do I need to multiply this fraction by to make it look like this, so that they both have both terms in the bottom? I need to multiply it by this x minus 5. So I'm going to go ahead and multiply the bottom and the top times x minus 5. When I do that, I have, let me go ahead and make some space here so you can see. I need to multiply the bottom times x minus 5 and the top times x minus 5. So on the top I have 7 times x minus 5. On the other fraction, I have to do something very similar, but this x minus 5 is just missing this x minus 2, so I'm going to multiply this other fraction by the other denominator. I'm going to do, so I can multiply it by the x plus 2. So I'm going to multiply this one, x plus 2, and x plus 2 on top. Whatever I do in the bottom, I have to do to the top so that I can make these equivalent fractions. Now, on the top, when I combine these fractions together, I'm going to be left with 4 times x plus 2. So let's trace back a little bit real quick and see how we got from this point A to point B. The first thing I noticed is that both of these were different denominators, so I need to make them the same. So I'm going to multiply them together and put them together in the bottom. And what I'm going to technically do is I'm just going to cross multiply. This x minus 5 is going to go up here, x minus 5, and this x plus 2 is going to go to the other side. Right? Now both terms have x plus 2, x minus 5, x minus 2, sorry, this should be a plus, x plus 2, x minus 5. I have the same terms in the bottom. The numerator is the only one that I had to add to keep them the same. If I go ahead and cancel these, notice how I'm left with the original problem, and if I cancel these, I'm left with the original problem. But I don't want to do that. I want to make sure that they have the same denominator so that I can do what? Combine the numerator. Now that the denominator is the same, I can combine the numerators. So I'm going to go ahead and distribute this right here, 7x and the 7 times negative 5 and the 4x times 2, and I'm going to get 7x minus 35 over x plus 2 times x minus 5 plus 4x plus 8. Again, this is through distributive property. And the bottom I have x plus 2, x minus 5. Again, the purpose here is to have the same denominators so I can combine the numerators. So when I do that, I'm going to combine like terms. And in the top, I'm left with 7x plus 4x, which gives me 11x. Negative 35 plus 8. When I subtract those, I get negative 27 divided by x plus 2, x minus 5. Is there anything that can cancel from the top in the numerator and in the denominator? The answer is no, and that is our solution. Let's try another example, and this will be our last one. Okay, so here notice how we have two different terms. So I'm going to first factor this one. So let's rewrite this problem where this one is factored. I'm going to write this in black so that you can see that it's the same problem. I have 8 over x plus 7 plus 4x divided by, I'm going to go ahead and find the factors of the denominator. And I did a video on factoring where we did 3 columns, and I helped you review a little bit on how to do that. So I'm going to factor this x squared plus 9x plus 14, and I know that I'm going to have the two factors of x plus 7, x plus 2. Now that I have it in factor form, I can see that these two fractions, I cannot combine them just yet until they both have the same denominators. Notice how they both have an x plus 7 in common, but this one has an x plus 2 and this one doesn't. So I'm going to go ahead and multiply this one times whatever is missing so that I can keep these two balanced, and then I can combine the two fractions together. So my goal is to multiply this fraction times the x plus 2 so that they both have an x plus 7 and an x plus 2. Now, since I added an x plus 2 on the bottom, I have to include it as well in the top. And I'm left with this. I have 8 times x plus 2 divided by x plus 7 times x plus 2. And in the other fraction, I have a 4x divided by x plus 7, x plus 2. Notice how Now I have common denominators, which means I can combine the numerators. I'm going to go ahead and do the distributive property here. Distribute, you're going to get an 8x and a 16. When you combine it with the 4x in the top and I combine all the like terms, I have, let's see, 8x plus 16. Over here I have a plus 4x, x plus 7, x plus 2, x plus 7, x plus 2. Now that I combine the numerators, I have 8x plus 4x, which gives me 12x plus 6 divided by x plus 7, x plus 2. And that is my answer. Now, I do notice that the 12x and the 6 have a 6 in common. So if I wanted to factor out this one on top, this is what I would get. If I factor out a 6, I would be left with 2x plus 1 on top, divided by x plus 7, x plus 2. Is there anything in here after factoring that would cancel? Would anything here in the top and the bottom cancel out? And the answer is no, which is why I knew that my answer was over here. There's no need to show this step over here because nothing is factorable, which means I can't cancel anything at all. So here's my answer. All right, guys, well, hope this helps. Let me know if you have any questions. I'm going to do a video here shortly on subtraction, which is going to be very similar. We're just going to add the subtraction symbol in between these two fractions. We still are interested in having a common denominator so we can combine the numerators. All right, guys, calculator.